بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على أشرف المرسلين وعلى آله وصحبه أجمعين. Today we will discuss principles of infectious disease epidemiology. Principles of infectious disease epidemiology by Professor Mahmoud Hani Sulaiman. General terms and definitions. When we mention these general terms and definitions, we mention them because they will be used many times during our lectures in epidemiology. Infection and infectious disease. Infection equals entry and development or multiplication of an infectious agent in human. Entry, development, or multiplication of an infectious agent in human. With response, for example, immunological response, in human, of course. So it is entry and development or multiplication of an infectious agent in human with response, for example, immunological response. Infection does not mean infectious disease. Infectious disease is a part of infection which is clinically apparent. So disease means a clinical apparent symptoms and signs. So prevention is interested in infection and its dynamics, not only the disease. The disease is part of infection, but epidemiology is interested in infection as a whole and its dynamics, including subclinical cases, carrier state, reservoir of infection, and its modes of transmission. This is the infectious disease part of this process. Colonization equal presence of infectious agent in human body, but without any specific host immune response. So colonization is presence of infectious agent in human body, but without any specific host immune response. Endogenous infection. Endogenous infection. It is the infection due to colonizing agent. For example, E. coli normally colonizes human GIT. However, under certain circumstances, it enters blood and leads to endogenous infection. So colonization without host immune response. Endogenous infection, the organism which is colonized, for example, E. coli in GIT, enter blood and lead to endogenous infection. Contamination equal infectious agent present in inanimate gamete. Contamination is agent present in inanimate articles as food, water, linen, patient care items, or routine use items like toys. The term denotes presence of infectious agent on skin surface, especially on hands. It denotes presence of infectious agent on skin surface, especially on hands. Pollution, presence of infectious agent or other noxious agent, or in general environment. So pollution means presence of infectious agent or other noxious agent as industrial effluents or mechanical agents as sound in general environment. General environment includes air, water, soil, and so on. Infestation equal humans, animals, or personal items where it is either due to infestation in humans or animals or personal items. Presence and development of insect vectors on body or linen. Presence or development of insect vectors on body or linen. On mucous membranes as roundworm infestation. Infestation also used for describing when accommodation or articles have presence of arthropods or vectors. Communicable disease equal one that is due to infectious agent transmitted or between humans. So communicable disease is one which is due to infectious agent or its toxic products, as toxins of Clostridium botulinum, and transmitted to human either directly or indirectly. Indirectly means through food, water, insect vectors, and so on, or disease transmitted between humans and animals. Important, all infectious diseases are not necessarily communicable, e.g. osteomyelitis or brain abscess are infectious disease but not communicable. Similarly, an infectious disease may be communicable in one form, for example pneumonic plague, but not in other form as bubonic plague. Dead-end infection, a state when infectious disease which is communicable cannot be transmitted any further between human beings or from humans to animals or vice versa due to various agent, host, and environmental regions. Examples: rabies, tetanus, bubonic plague, scrub typhus in humans. Dead-end infection, when a dog transmits rabies to a human, the human cannot transmit it to other human or animal. Subclinical infection, or you may say inapparent infection. Subclinical infection, when agent multiply in host body but there are no clinical manifestation of disease, no symptoms or signs. So infection not recognized clinically, though infectious agent may pass out of human body, and hence a person with subclinical infection is a greater health hazard for community. Disease as viral hepatitis A have large number of subclinical cases, but disease as measles hardly have any subclinical infections. So infections with many subclinical cases are less easily prevented, but disease with very few subclinical cases are more easily prevented by surveillance methods. Latent infection, when infectious agent lies dormant in host body without any symptoms or signs, but does not come out of human body. After a period of time, under certain conditions, agent which was lying dormant may reactivates and produces a different type of disease, e.g. herpes zoster, or same type of disease, e.g. TB reactivation. So the dormant organism may reactivate and produces a different type of disease, like happens with herpes zoster, or same type of disease like happen in TB. Zoonoses. When infections transmitted between vertebrate animals, either directly or indirectly by vehicle or insect. Zoonosis, a disease transmitted from vertebrate animals to humans, directly, indirectly, or vehicle insect. Health important ones transmitted to man from vertebrate animals, either directly, indirectly, or through vehicle or vectors, called anthropozoonosis, include a long list of infections as rabies, plague, bovine TB, salmonellosis, Japanese encephalitis, scrub, and murine typhus, echinococcosis, anthrax, brucellosis, and so on. A long list. We will describe them in the chapter of zoonoses. Second group are infections primarily infect man but can be transmitted to animals, called zooanthroponosis. Third group is amphizoonosis, includes infections may be transmitted from man to animals and vice versa. Opportunistic infections equal disease due to infectious agents, normally not pathogenic, but due to decrease in general or specific immune status of host, turned pathogenic. In normal conditions, it is not pathogenic, but due to decrease in general or specific immune status of host, it turns pathogenic. Term assumed greater importance following identification of HIV. Sorry, I may sometimes pronounce it HIV. It is a special pronunciation from me, not real one. So HIV infection, whose symptoms and signs comprise of a wide variety of opportunistic infections as cytomegalovirus and other infections. Nosocomial infections means infection due to hospital. A nosocomial infection equal disease contracted while in hospital due to healthcare or related procedures. So diseases taken while in hospital due to healthcare or related procedure. Such infections include those whose symptoms and signs may start after discharge from hospital, but not those which were incubating in patient's body at time of admission. So the beginning of taking the organism inside the body must begin at hospital. Eradication. What we mean by eradication of an organism? It is complete cessation of transmission of infectious agent. Complete cessation of transmission of infectious agent. Smallpox is the only example. While look at the bottom, elimination equals either regional eradication, say from a country or continent, or of disease comes to zero without total removal of infectious agent from environment. So elimination means it is removed from a country, a specific geography, or this disease at this country with its incidence and the prevalence come to zero without removal of infectious agent from environment. The famous example is polio. Control at the middle of the slide. Control. What is control? Control is decreased transmission, so it is not a public health problem. Control needs ongoing preventive measures, consequently continuing expenditure along with efficient surveillance system. It is pronounced surveillance because it is a French. Surveillance means observation. Efficient observation system to give early warning of increased level of transmission. Again, we will define control. What is control? Look at the arrow. Decrease the transmission, so the disease is not a public health problem. Control needs efforts, needs ongoing preventive measures, consequently continuing money, continuing expenditure, along with efficient surveillance system to give early warning of increased in level of transmission. It needs time, efforts, money, manpower, and good knowledge of epidemiology. Epidemiologic chain of infection. 4 related factors referred to as epidemiologic chain of infection. What are these factors? It is infectious agent, human host, interaction between agent and host, modes of transmission. We will discuss each of these, but these 4 items, the 4 factors related to chain of infection are the agent of infection, the host or human host of the infection, the interaction between agent and host, and modes of transmission. Agent. 3 broad groups of characters important of agent of about agent of infectious disease. First, reservoir and immediate source of agent. Second, agent survival in environment. What leads to this survival and what prevent this survival. Third, characters of agent determining production of infection. Reservoir and immediate source of agent. Any infectious agent has a primary habitat called reservoir of infectious agent. Reservoir of infectious agent. It may be a person, animal, or inanimate environment like soil where an infectious agent lives. Where an infectious agent lives, and from there it propagates so it can be transmitted to a human host. So it is where the agent lives, either person, animal, or inanimate environment. From where he lives, from where it lives, it can propagate to a human host. On the other hand, a source of infection is person, animal, or their excretions, or inanimate environment from where infective form of agent is available to susceptible human host. The source of infection may be animal, person, or their excretions, or inanimate environment. And then this source transmit it to a human. Let us talk by example because this will make things easier. The example here is hookworm. Adult forms live in human gut, depending on human for their survival. They multiply inside humans, eggs passed out and transmitted to another human. So propagate species. Worms do not depend for survival or multiplication on any other animal, soil, plants. So reservoir of infection is human infected with hookworm. In this example, it is human reservoir. On the other hand, infection of another human being occurs due to skin contact with soil contaminated with infective stage larvae. So, infection occurs due to skin contact with soil contaminated with infective stage larvae. So, source is soil contaminated with infective stage larvae. Types of reservoir of infection. Firstly, most important reservoir for most of human infections is human reservoir. Human reservoir can be either cases or carriers. The cases are those with clinically apparent disease. The carrier is the human harbors infectious agent, sheds it, but does not exhibit any symptoms or signs of disease. These carriers cannot be detected, so carriers are extremely important because they are hidden, and so we must search for them and prevent them from shedding the organism in the environment. Carrier is either during incubation period, incubatory carriers, like in measles, mumps, hepatitis A, and so on. Importance of incubatory carriers due to after incubation period ends, disease appears. We isolate, treat patient, but he can transmit disease during incubation period before the symptoms and signs appear. Secondly, human reservoir may have subclinical or clinical inapparent disease. The inapparent disease can be a contact or healthy carrier, like hepatitis A, cholera, poliomyelitis, diphtheria. A subclinical carrier should be differentiated from a subclinical case, which refers to a person with infection after incubation period but do not show symptoms and signs and do not shed organism. The subclinical case, he is after incubation period, do not show symptoms and signs, but do not also shed organism, so infection not transmitted to others. E.g. of subclinical case of Japanese encephalitis, in which infectious agent is present in body, but low titer viremia is inadequate to infect mosquito vector. We are still explaining reservoir of infection. Thirdly, person may continue to shed infectious agent even after recovery during convalescent stage, and hence known as convalescent carrier, like in cholera, typhoid, bacillary dysentery. Such carriers may be of short-term or temporary carriers, less than 4 weeks, or chronic carriers more than 4 weeks, may be up to years, as in chronic typhoid infection of gallbladder. Animals and other forms of reservoir. Animals form another reservoir where infectious agent lives, primarily multiplies, and is available for being transmitted to human host. These diseases fit in scope of zoonoses. Finally, some infectious agents like fungi may primarily thrive and multiply in contaminated soil. The last two types of reservoir are animal reservoir, which are zoonoses, and contaminated soil. Characters of agent concerned with survival in nature. This is called survival capacity in nature of organisms. Some agents can hardly survive outside human body, like measles and chickenpox. Others survive for limited time if conditions are favorable, like the cholera, polio, hepatitis A. Can survive in water, ice, sewage, and milk. HIV can survive in blood and blood products. However, all of them are vulnerable to drying, heat, and disinfectants. This is important when we are talking about removal of these organisms from where they are present. Characters of agent concerned with survival. Finally, some organisms or their intermediate forms can withstand adverse environment very well, like Clostridia spores, cysts of intestinal protozoans, ova of helminths. Usually, agents with very poor survival in nature have direct modes of transmission as droplet infection or direct mucus contact. So, it is like these creatures are given methods to overcome their vulnerability. Also, survival in nature becomes more crucial for agent if human is the only reservoir. Characters of agent that produce infection and disease. Infectiousness equals relative ease of agent to transmit disease to host. It is a function of environmental factors. For example, in measles, this disease increase in overcrowdedness but decrease in rich community because this community is not crowded. Infectivity is the ability of an agent to produce infection. That is to say, to enter, survive, and multiply in a host. An epidemiologic measure of infectivity is secondary attack rate, SAR, defined as number of susceptible persons who, during duration of one incubation period following exposure, develop disease, divided by total exposed susceptibles. SAR measured by doing studies in close communities or families where first case with infection caused disease. It is called the index case. The formula for SAR is number of susceptibles exposed to index case who develop the disease within the duration of maximum incubation period of the disease, divided by total number of susceptibles exposed to the index case multiplied by 100. Pathogenicity equal ability of agent to produce disease with symptoms and signs divided by number of those who were infected. Agents with increased pathogenicity resist non-specific host defenses and produce toxins, as in case of diphtheria and tetanus, or may lead to host immune response to disease, as happened in rheumatic fever and glomerulonephritis. Virulence, more important than infectivity and pathogenicity. Virulence is the ability of an agent to produce severe disease. Ability of agent to produce severe disease. If serious infection measured in terms of death, so case fatality ratio is a good measure of virulence. Infective dose is important in certain diseases such as Vibrio cholera, Salmonella typhi. So if inoculum is not adequate, infection will not settle, or at least manifest disease will not occur. On the other hand, in infections as plague, even very small dose may be enough to cause infection. Host factors. Host factors which determine dynamics of infection fall into two broad categories, A and B. Host attributes affecting probability of exposure to infectious agent. These include many factors. In this slide, there are 4: age, sex, economic status, and occupation. Age. Young children, due to hygienic innocence and habit of orally exploring items, they are more susceptible to exposure to soil-transmitted helminthic infections. 6. Females are leading a mainly indoor life, so they are less exposed to sylvatic zoonoses as rabies. Economic status. Poverty, squalor, and infection form an almost one consolidated group. Occupation. Agriculture and veterinary workers, for example, are more exposed to certain zoonoses. In this slide of host factors, we will discuss education, living conditions, lifestyle, and use of personal protective measures. Education. When we increase knowledge of causation and prevention of infection, this will help in decreasing exposure and so decrease the prevalence of the disease. Living conditions. Poor housing, overcrowding, lack of sanitary eating, drinking facilities will increase chances of exposure. Lifestyle and behavioral factors. Permissive attitude toward sex increase probability of exposure to reservoir of sexually transmitted diseases. Use of personal protective measures. For example, use of mosquito nets, repellents, will decrease chances of exposure to mosquito-borne diseases. Once a host exposed to infectious agent, certain factors will determine disease occurrence and severity. These include status of host immunity, age, genetic makeup, and availability of health services. Status of host immunity, whether actively or passively acquired. Age, extremes of age and very young age versus very old age are more susceptible. Genetic makeup known to occur in respect of some diseases like TB and malaria. Availability and utilization of health services by providing chemoprophylaxis, immunization, health education at the primary preventive level, early diagnosis and prompt treatment. Herd immunity. إنما يأكل الذئب من الغنم القاسية. That is to say in English, wolf eats sheep which is away from his herd. Herd immunity means group immunity. It is the immunity of population against an infectious agent. This herd immunity leads to protection of population from infection, protection done by presence of immune individuals. So, if a large percent of immune persons are found in a community, this will decrease probability of persons to get infectious agent or to transmit it to another susceptible person in same population. For example, on childhood infections, disease prevented by immunization, vaccination covering of about 85% mostly provide adequate herd immunity, leads to effective block of disease transmission, even if remaining 15 children are not immunized. At the end, factors affecting process of infection as a result of interaction between agent and host. There are certain features which are peculiar to each infectious disease as follows. Incubation period equals period between entry of infectious agent into body till earliest apparent symptoms and signs. During incubation period, no symptoms and signs, but immunological, histopathological changes in body occurs. If during IP organism shed from host body, he is an incubatory carrier. IP measured as a median IP, that is to say, time in which half of infected subjects develop symptoms and signs after organism entry in body. Along with median incubation period, a range is also given. Incubation period calculated by studying time taken for onset of secondary cases following exposure to index case in family groups or enclosed communities during investigation of common vehicle point source epidemics. Different diseases have different values of median incubation period and range. All physicians and students must remember them well. Uses of incubation period. These are very important. Helps in making diagnosis. Because short incubation period helps in making diagnosis as in food poisoning, gonorrhea, and donovanosis. Helps to trace contacts or source of infection, as in disease with short incubation period. This is helpful to implement control measures. It is also used for quarantine purposes. Quarantine means to limit movement of healthy persons. First, it was used in disease to prevent diseases through travels, as those smallpox, cholera, plague, yellow fever, and it is used in COVID-19. Frequency of disease. Epidemiology observes number of cases of a disease, convert it into a frequency measure called incidence or prevalence by relating number of cases to population at risk. Depending on frequency of disease, the disease may be epidemic, which means occurrence of disease frequency in a defined population area which is in excess of regular expectation. Sporadic, few scattered cases of infection which do not have any relation to each other, either place or time. Endemic, continued transmission of a disease in a defined population or area at a relatively low without any importation from outside area or population. Difference between epidemic and endemic is high frequency, abrupt increase in occurrence in epidemic situation, compared to continued transmission in endemic situation. Channels of transmission. Two endpoints for this channel of transmission, agent and host. To complete this link, it must be transmitted from agent to host. Two methods for transmission, either direct or indirect. Direct modes of transmission. Four methods of direct transmission. First, contact of host skin or mucous membrane with infectious agent contained in a living tissue, sexually transmitted disease. Second, contact of skin or mucous membrane with infective form of agent contained in inanimate environment, like hookworm and leptospirosis. Inoculation of agent directly from reservoir into skin or mucous membrane, as rabies. Vertical transmission from mother to child through placenta, e.g. HIV, syphilis, and torch agents. Direct methods of transmission. Direct transmission due to agent in close distance of host, as in droplet infection. Droplets are very finely dispersed aerosol containing infectious agent, formed when a person harboring agent in respiratory tract, coughing, sneezing, and talking. If another host at close distance, usually 1 meter or less, infective droplets directly deposited on mucous membrane of oral cavity of respiratory passage of the host. Examples: TB, common cold, influenza, measles, mumps, pertussis, diphtheria, meningococcal infection, leprosy, and others. Indirect method of transmission. Infectious agents require an intermediary agency to convey it from source of infection to susceptible host. Types of direct modes of transmission: vehicle-borne. Vehicles are anything eaten, anything drunk, anything injected. يبقى anything eaten, anything drunk, anything injected. It's very easy. Anything eaten like food and sweets. Anything drunk like milk and water. Anything injected like blood products, drugs, vaccines, and so on. Fomites, which are inanimate objects of general use by infected person, like utensils, linen, pens, and so on. Infectious agent may remain on surface of such fomites and may be transmitted to host when such objects are put into mouth or come in contact with conjunctiva. Fingers are also a very important mode of indirect transmission. GIT infection are examples of these transmitted by fingers. Air droplets containing infectious agent may dry or may settle down on dust. If agents survive environmental conditions like drying or heat, it can be carried for long distance by air currents along with dust or droplet nuclei. If deposited on portal of entry of a host, it will lead to infection. Again, droplets, the organism settle down among dust, then it survives environmental conditions, then it is carried by air draughts, carried for long distance by air currents, and if it enters into a mouth of a host, it can cause disease. The examples are Legionnaire disease, Q fever, tuberculosis, nosocomial infection. Here is an important note. Airborne infected nuclei and dust should be differentiated from droplet infection. It is not droplet infection. It is called airborne. It is carried by air. As explained, droplet method is a direct method of transmission which agent is directly deposited from immediate source of infection onto a portal, and a distance between both the source and the host is at maximum 1 meter. While in airborne, we said agent is not directly deposited from source of infection to the portal of entry of host, but transported indirectly by air over long distance. This was important and is still important in COVID-19. Vector-borne indirect transmission. A vector is a living invertebrate, mainly arthropod, to less extent it is snails. This transmission firstly can be either mechanical, as when housefly carry on their surface the organism, as housefly, which mechanically transmits a number of orofecal disease agents from feces to food. Also, it can be biological transmission. Biological, as a stage in its life cycle, happens in the vector. This may occur in three ways. Example of plague bacilli multiply and increase in number in mouth parts of rat flea. This is propagative mode. Or cyclo-developmental, as when female Culex mosquito takes microfilaria with blood meat. 3 larval stages end by infective stage larva inside the female Culex. Finally, after ingestion of malaria male and female gametocytes with blood, life cycle occurs inside the mosquito. There are developmental changes in life cycle also for one male and female gametocyte taken by mosquito. Thousands of sporozoites formed, so developmental changes and multiplication occur. It is a cyclopropagative. يبقى propagative, cyclo-developmental and cyclopropagative. وفي النهاية لا أجد إلا أن أشكركم وأقول الحمد لله الذي بنعمته تتم الصالحات.